Hey y'all, a couple of you asked me to make a video for today's classwork, this pre-review, so I did, or I'm going to. All right, here we go. The first question today asked for the area and the perimeter of this regular hexagon. Regular means just it has all the same sides and all the same angles. And the only information we got that all the way across it is 30 inches, I think. Inches, yeah. Brushes, black, inches, purple. Let's go. Okay, the first thing we're going to do here is we're going to divide this into 6 equal triangles to kind of like manage it. We're going to cut this into 2 parts. So this 30 inch line is going to cut to 15 and 15. And then we're also going to find this upper angle for each of these triangles. The way we're going to find this is we're going to do 360, which is all the way around, divided by 6. Because there are 6 triangles, and we're going to get that each of these angles is 60. All right, so that's a 60-degree angle. Now, I'm going to take this triangle, I'm going to draw it over here. So this one. I'm going to draw it over here just so I can have a little bit more visibility. I've got my altitude, which is the height. They told us that was 15, and this is a right angle. We know that this entire angle is 60, so if we cut it into 2 pieces, each of them are 30. And what we desperately want is this base side length. Because if we get the base side length, we can add them all together and get the perimeter. Also, the way to find the area of each of these triangles is the base of the triangle times the height. We've already got the height, we just need the base. Okay, in order to get the base here, let's do blue, it's pretty. In order to get x here, we're going to use the tangent of 30 to get x over 15. The tangent is always the opposite side over the adjacent side to this angle. X is our opposite side to 30, and 15 is our adjacent side to 30. We can set up this tangent equation. We can plug in tangent of 30 into our calculator. Tangent of 30 equals, get 0.577. Then we can multiply that by 15, get the 15 out of the denominator, and solve for x. Again, what we just did was we multiplied each side by 15 so that we could get that this is 8.66. That means this is also 8.66. And if we add those two together, we get the base of the triangle is 17.32. We already know the height of the triangle. That was 15. And now we can find the area and the perimeter. The perimeter is just 6 times the base, because there's 6 bases that we're adding together to go all the way around the circle. 6 times 17.32 is 103.92, and it will be in inches because perimeter is just a bunch of lines. Great. The area here will be the area of these triangles, so 1/2 base times height times 6, because there are 6 triangles. So I'm going to do 1/2 times 17.32 times 15 times 6 and get 779.4. Area is a 2-dimensional thing, so it'll be inches squared. That was fast, but hopefully you can put it on, half-time speed or something. All right, for this next one, we've got the equation for area, which is pi r squared. We've got the equation for circumference, which is 2 pi r. We've got the sector area equation, which is pi r squared times our angle in degrees over 360. And we've got our arc length formula or equation, which is 2 pi r times our angle in degrees over 360. All of these equations use r, and half of them use theta, which is a degree. Our radius here is 7. It told us our radius was 7. And our theta, we actually need to put this into degrees before we can plug it into our equations. So let me actually give it some space. Let's change 2 pi over 3 into degrees. If we want to do the unit conversion way, we would say I no longer want radians, I do want degrees. I can cancel these and do 360 divided by 3 and get that our theta is 120. That's the unit conversion way. We can do the ratio way, where we've got 2 pi over 3 over 2 pi. That equals x degrees over 360. We can cross multiply. So that's 2 times pi times 360, still divided by 3, equals 2 times pi times x. If there's a 2 on both sides in the numerator, we can cancel them. If there's a pi on both sides in the numerator, we can cancel them. So we again get that 360 divided by 3 is x, which is still 120. Great. So we've done our conversion. We now know our radius and our theta, and now we can plug it into our equations. Area then becomes pi 7 squared, which is 49 pi. Circumference becomes 2 times pi times 7, which is 14 pi. Let me write that better. Sector area becomes pi times 7 squared times 120 over 360, which becomes 49 pi. I'm going to simplify this. Both of these can divide by 120. This becomes 1, this becomes 3. So this is 49 pi over 3. And same thing here. We can do 2 times pi times 7 times 120 over 360. 2 times pi times 7 is 14 pi. This again simplifies to 1/3. So we can put it over 3. You, of course, are allowed to just put this into a calculator, like put this into a calculator and get the decimals. The decimals are, oh gosh, this one's 153.86. This one is 43.96. This one is 51.3. And this one is 14.66. And again, I'm having trouble writing a 14 for no reason. Oh, Miss Power, what about units? Great question. Both of the areas will be inches squared, and the circumference and the arc length will just be in inches. Here, when we want to find missing side lengths, we can use trig. So I don't have the hypotenuse, I do have the opposite, and I don't have the adjacent for 52. I'm going to use tangent to find y first. Tangent of 52 is 7 divided by y. I'm going to plug tangent of 52 into my calculator and get 1.28. Then I'm going to cross multiply, get 1.28y equals 7. Then I'm going to divide by 1.28 on both sides to get that y equals 7 divided by 1.28, which is 5.47. Could I have done this another way? For sure. I chose this one because I now want to use the two legs, the two shorter sides, to find my hypotenuse, right? I know that 7 squared plus 5.7 squared is x squared. So this is 49, 5.47 squared. Where's the squared button? Boom. is 29.92, 29.92. I'm going to add those together. 78.92. And then I will square root both sides to get that my x is like 8 point something, right? 8.88. All right. Number 4. This angle marker means that this is 90. Anytime we have the arc measure, it's the same as our central angle measure, right? Whenever our arc and our central angle share endpoints, they're the exact same angle. And then, as always, the entire circle adds up to 360. So x becomes 360 minus 90 minus 120, which is 150. I'm pretty sure. Yes. Great. For this next one, this arc being 50 tells us this arc back here, this angle back here, is 25. This is because we've got an arc and an inscribed angle, not a central angle, but an inscribed angle that have the same endpoints, right? The arc 50 has those two endpoints. The inscribed angle x starts where the arc starts, goes to the back of the circle, and ends where the arc ends. This is when we get to cut them in half. In the same way, this half of the circle is 180 degrees because it's half of the circle, which makes z equal to 90, which is half of 180. To find y, I do 180 minus 90 minus 25 and get 65. Cool. Are there other ways to do that one? Absolutely. Definitely. For this one, we have an inscribed angle that start and stop at the same point of this arc. So this arc is double that angle, is 40 times 2. So this red one, this red angle starts and stops at the same points as the arc. The angle y also starts and stops at the same place as the 80-degree arc. So y is going to be, because it's an inscribed angle that ends at the back of the circle, it's going to be half of 80. So this will also be 40. Cool. If Wednesday's classwork was confusing, hopefully that helped out. And you can study with this as well as the review.